Hello, we're in Chapter 7. This is Section 6. This is page 2 of the notes. We have an example where we have to solve this equation 6 to the x equals 27. Now, the exciting thing here is that, in fact, the x is in the exponent. Ha ha ha. So, the problem is that the thing's in the exponent. You need to not have it be in the exponent, and the way to solve that is to write it in logarithmic form. So the thing is set up to it says take, and then what they want you to say is log base 6 of each side, and that's okay. I think that's actually kind of a crummy description of what's going on. What we're really doing is writing in log form. You practice this in the first section of this half of the chapter. So what we're talking about is that, in fact, I would even just go ahead and say this is log base 6 of 27 equals x. Boom. You write it in log form. You're there. X equals, it's log base 6 of 27. And then that's nice, but you likely don't have a log base 6 button on your calculator. So in order to work through this, you need to change the base. This was in the last section, and so you have a choice. You can do common log 27 divided by log 6, or you can do natural log 27 divided by natural log 6. I like natural log better personally because it is more betterer, but more importantly, it's 2 letters to write instead of 3. But whatever. Either way, you'll get about 1.84-ish, depending on how much you choose to round. So the answer is about 1.84. There you go. All right, moving on to the next example. Same idea, but this one's a little more complicated. We have 6e to the 0.25x plus 8 equals 20. And, it's a lot of stuff going on here. So, you got to begin by, get rid of the 8, right? You got to subtract 8 from each side. When you do that, you get equals 12. Boom. Subtract 8 from each side. You're looking at that, you're like, that's all well and good, but this 6 is trouble. Divide by 6. All right, divide by 6. So you end up with 2. And we're talking about e to the 0.25x equals 2 after you divide each side by 2. Okay, now change it into log form, right? So x is in the exponent. We don't really want that in terms of solving the equation. Change it to log form. So log base e of 2 equals 0.25x. And that's, that's adorable until you remember that nobody actually writes log base e. We write ln. So 0.25x equals ln of 2. Not quite done. Divide both sides by 0.25 to actually figure out what x is, and you get about 2.77. The trick, when the x is in the exponent, change the form to log form. So it's about 2.77. And the book says, check this. Of course, you really should. There are going to be some things that happen. They're not good. Check them. Extraneous solutions happen. They don't happen quite here, but you may not want to trust yourself to discern when they're happening and when they're not. I would really recommend you take 2.77-ish, put it back in the equation. It won't be exactly 20, but it will be pretty close to 20. Boom. You'll be in good shape here. Okay. Now, here's the checkpoint. All right. So here's what we're going to do. I recommend that you go ahead and pause this and try, 1, 2, 3, or 4 of them. I'm going to wait for a few seconds so you can pause it and try on your own. And then when you've tried it, come back and see how well you did. Hey, here we are. So that's the answer to number 1, which is that x equals 1. Eh, who knew? Uh, but if you do that, you end up with it working. The trick here is, of course, to notice that 9 really is better written as 3 squared. That way the base matches the base on the left. And then you play the fun property rule. Squared to the 2x really means it multiplies into 4x. And then since the bases are the same on the left and right side of the equation, you don't have to worry about the bases. Just make the exponents match. So 7x minus 3 equals 4x. Boom, solve x equals 1. That was fun. It really is. But numbers 2, 3, and 4 are all slightly different. So please go ahead and try number 2 if you haven't already. I'll still be here when you get back. Hey, welcome. Here we are. The answer is 2.657-ish, and that depends on, whether you use a common log or natural log, but either way you get the same answer. The trick is noticing the thing you want, the x is in the exponent, so you've got to flip-flop it around and turn it into log form. Then change base. I prefer the natural log version of changing base, but hey, the common log makes people more comfortable because they feel like they know what they're writing. It doesn't matter. It's all good. Either way, you end up with the same number. Okay, number 3 is a little more complex than number 2, although it really does work off the same basic ideas. Try that one on your own. I'll still be here. Okay, welcome back. This number 3 was a bit longer here. You got to start by moving that 6 around, right? So you got to add 6 to both sides. You end up with 11. Then you still have the x in the exponent, so you got to change it into log form. Log base 8 of 11 equals 3x plus 2. That's great, but log base 8 of 11 is not something that your calculator is likely able to work with for you. So I traded it into ln of 11 divided by ln of 8. You could have done log, common log, instead. Doesn't really matter. Then subtract 2, then divide by 3. I wrote it all out exactly here in the end until the end. I know it's a little gross to look at, but the reason why is there's a lot of rounding that happens when you do that natural log of 11 divided by natural log of 8. And I don't want the rounding to cause problems later on. So if it's possible for you to do it exactly, you're going to have slightly more exact answers along the way. You might prefer that. Okay, number 4 is actually easier than number 3, but yet it's different. Try it on your own. I'll still be here when you're done. And here we are. So this, like the prior problems, has x in the exponent, but you've got to get rid of all the extra junk that's hanging around like some sort of rap crew wannabe. So you got to move the 2 off first. You got to subtract 2 from both sides. That leads you to this line here: 3e to the 0.5x equals 3. Then you got to divide both sides by 3, so e to the 0.5x equals 1. That's great. Trade it in for log form because the x is in the exponent. Boom. 0.5x equals natural log of 1. Because this one has e as the base, you really want to do natural log here. Trust me. And then divide by 0.5, and it ends up as exactly 0. It's, of course, adorable that the book thinks somebody can solve these checkpoints easily in these small boxes. Delusions are always amusing. That's it for page 2. Thank you for watching.